We are going to see about law of multiple proportions. Okay, first, what is mean by law of multiple proportions? Okay, the explanation for when two elements A and B, any two elements is reacting with each other, any two elements is reacting with each other and combine to form two or more compounds. It is giving the products two or more compounds. Okay, then different weights of B, the different weights of B which combine with their fixed weight of A bears a simple numerical ratio to one another. So, any substance we are taking A plus B, any substance, any reactant we are taking here, and it will react with each other and it will give some products. Okay, in various products it will give, not one product, it will give various products. Okay, so that B, the second reactant having that mass will be in a simple numerical ratio. So that only we are going to prove. Okay, now simple example for this: carbon and oxygen are reacting with each other and it forms two various oxides, carbon monoxide and carbon dioxide. Carbon and oxygen is reacting with each other and it will give two various oxides, carbon monoxide and carbon dioxide, CO2. So in this, the B substance, this one only B substance, here A plus B I told, no, so like that here this one is A and this one is B. This B, this substance mass in the two different oxide will be in what ratio? Means it will be in simple numerical ratio. For example, 1:2, like that. The ratio of that B will be a simple numerical ratio. Oxide C/O ratio will be 12:16, and carbon dioxide here CO2 will come. So for carbon dioxide, this will be the ratio. It will be simple numerical ratio. How we have to calculate for carbon monoxide? What is the formula? Carbon monoxide C and O. Okay. What is the atomic mass for carbon? It will be 12. And what is the atomic mass? Mass of oxygen is 16. Like that, mass of carbon is 12. So C/O, carbon versus oxygen ratio is 12:16. How we are writing? Because carbon mass is 12 and oxygen mass is 16. Now write the next oxide formed. What is the next oxide? Carbon dioxide. Okay, carbon dioxide means CO2. So what is the ratio here? For carbon, the atomic mass is 12:16. Oxygen, here one oxygen present, so we written here 16. Here two oxygen, so 16 plus 16, which is equal to 32. So this is the next ratio. Okay, now the B compound, which is the B compound here? Oxygen is the B compound. So the oxygen ratio in first oxide and the second oxide, it will be a 1:2. So it will be a simple numerical ratio. And this is the explanation for multiple proportion. Prove the multiple proportion through some problems. In an experiment, 34.5 gram of oxide of a metal was heated. Metal oxide, this is the value for metal oxide, was heated so that oxygen was liberated and 32.1 gram of metal was obtained. Here they given the metal value and metal oxide value. From this we have to calculate oxygen value. Okay, they already given metal value and metal oxide value, they already given. From that we have to calculate oxygen value. And next one, in another experiment, 119.5 gram of another oxide of the same metal was heated and 103.9 gram metal was obtained. So here also they given the same way. Oxygen was liberated. We have to calculate in the second experiment also, we have to calculate oxygen value. Calculate the mass of oxygen liberated in each experiment. We have to calculate mass of oxygen liberated in each experiment. Show that the data explain the law of multiple proportions. So in two experiment also they given the metal oxide value and metal value. From that we have to calculate oxygen value. Then we have to calculate the ratio, oxygen ratio. Okay, shall we write for first experiment? first experiment. What is the weight of metal oxide? What is the value of metal oxide? They given 34.5 gram. Next, weight of the metal. Weight of the metal 32.1 gram. 32.1 gram they given. 32.1 gram. Now we have to calculate weight of oxygen. If we subtract these two means we will get the oxygen value. So 2.4 gram. This is the oxygen value. Here 32.1 gram of metal we are having. 32.1 gram of metal we are having. But 1 gram of metal contains how many oxygen? We have to calculate that. So we have to divide this 2.4 divided by 32.1. I will explain again. They already given weight of the metal oxide value. They already given weight of the metal value also they given. From this we have to calculate oxygen value. So I subtract these two. I subtract these two value and I got 2.4 gram. Then this is the value for 32.1 gram of metal. I have to calculate the value for 1 gram of the metal. So I am taking this oxygen value and divided by this 32.1. Then I got 0.075 gram. This is the oxygen value for 1 gram of metal. Like that, I have to calculate the second experiment also. For second experiment also, they already given the metal oxide value and metal value. From that, I have to calculate oxygen value for 1 gram of metal. And weight of the oxide taken, they already given the value. What is the value they given? 119.5 gram. Weight of the oxide taken and weight of the metal also they already given 103.9 gram. So from this I have to calculate weight of the oxygen. Weight of the oxygen value I have to calculate. So I have to subtract from these two values. I have to subtract. So the answer is 15.6 gram. So this is the oxygen value. This is for 103.9 gram of metal only. I have to calculate 1 gram of metal. Okay. This value for 103.9 gram of metal. But I need to calculate 1 gram of metal. So what I have to do, this 15.6 gram divided by this 103.9 gram. Okay, then I will get some values. 0.15014. This is the oxygen value, weight of oxygen value for 1 gram of metal. So this is the second experiment value. What is the first experiment value I got? See here. This is the first experiment value and this is the second experiment value. So, 0.15014 is to the first experiment value what I got here. I have to write on here. 0.075. So, this is what ratio means 2:1. The oxygen value will be in the ratio of 2:1. So, it is the simple numerical ratio. I will show you the second problem also. Problem: carbon forms two oxides which contain 42.8% and 27.27% of carbon. They given the value of carbon here. Okay, carbon value for first oxide is 42.8% and for second oxide is 27.2% respectively. But they didn't give the value for oxide value. They only given the carbon value only. Before problem, they already given metal oxide value plus metal value. Then we will subtract from each other. Then we got oxygen value. But here they given only about carbon value alone. We have to calculate the oxide value also. Okay. From that we have to subtract and we will get oxygen value. Show that these data illustrate the law of multiple proportions. Now we have to write for first experiment. For first experiment, what is the weight of oxide? what is the weight of the oxide. They didn't given here oxide value, they only gave carbon value alone. So we are taking 100 grams of oxide. Okay, afterwards we have to calculate for 1 gram. Okay, now second one, weight of carbon value they already given 42.8 gram. Now we have to calculate weight of oxygen value. We have to calculate from these two, we have to subtract, then we will get 57.2 gram, which is known as oxygen value. Okay, so this is for 42.8 gram of carbon combines with 57.2, but we have to calculate 1 gram of carbon. Okay, combined with oxygen means what is the value we have to calculate. So I am taking this 57.2 divided by 42.8 gram of carbon. I am dividing this one 42.8, then I will get 1.33 gram of oxygen. So this is the first experiment value. Like that, second experiment also we have to calculate. Second experiment, weight of oxide. They didn't given the weight of oxide value, so I am taking 100 grams. Then weight of carbon. Weight of carbon, what is the value weight of carbon? 27.27. 27.27 gram. Now I have to calculate weight of oxygen value. So I have to subtract these two, then I will get the value 72.73 gram. Okay, but this is for 27.27 gram of carbon combined with, but I have to calculate 1 gram of carbon. So I am taking I have to calculate 1 gram of carbon. So this 72.73 divided by this 27.27, then I will get the value 2.66 gram of oxygen. So this is the first experiment value, this is the second experiment value. So what is the ratio? Here I have to calculate the ratio. So first experiment value is 1.33 ratio versus here what? 2.66. This is the ratio. So this is 1:2 ratio. So this is the simple numerical ratio. So this is the explanation for multiple proportions. B substance, a carbon substance and oxygen substance, both are reacting with each other. Carbon and oxygen is reacting with each other and it is giving various products. The oxygen value for first experiment and second experiment will be in the simple numerical ratio, and this is the explanation for multiple proportions. Thank you.